which means universe reputation. And yeah, why we use Unirep? Because nowadays we have a lot of applications. Their own reputation system. For example, we have followers in a subscriber in YouTube or Airbnb and Booking.com reputation. And also we have Karma in Reddit. But how can we integrate them together in one reputation system? So Unirep is introduced here. And now I took an example. If Alice is an Airbnb user and she wants to prove to a Booking.com landlord that she has enough reputation to live. She has enough reputation in the Airbnb, but the landlord of Booking.com doesn't believe she has enough reputation. And now how can Alice prove to the landlord in Booking.com? The easiest way is that Alice can take a screenshot of the history of his Airbnb history. But now Alice's privacy will be compromised. And it's really easily to forge. And so that the landlord of Booking.com is hardly to be convinced. But now Unirep can solve this problem. Unirep is a private and non-repudiable reputation system. So user can give others reputation, and also he can voluntarily prove how much reputation he or she has. And also user cannot refuse to receive bad reputation. And now I will introduce the protocol behind the Unirep. So there are two actors in Unirep. The first one is the attesters, who will not be anonymous in this system, like Airbnb or Booking.com. It represents user to give reputation, like they can issue reputation token, and the users, which means the Alice or a landlord in Booking.com, and they are anonymous, and they can receive reputation and also prove their reputation. So others will never know that who receives this reputation. Yeah, so it can achieve privacy. And in this system, we define an epoch key to receive reputation. And also we define a period of time called epoch. For example, 7 days. And then in each epoch, user can have k epoch keys to receive reputation. And the epoch key is like a hash, so it is hardly to link to an identity, which is like Alice here. And in this system, when user signs up, and we use the identity system called semaphore. And semaphore consists of a private identity and a public identity commitment. So the user use the public identity commitment to sign up in the Unirep smart contract here. And there's a global state tree is computed, and it's computed by hash of identity commitment and the user state tree root. So we will introduce what is user state tree root in this protocol. User state tree root is how much reputation a user has in the Unirep protocol. So the index of the tree is the attester ID, and the leaf value is hash of all the reputation data. For example, the positive reputation, negative reputation, and graffiti, and also a sign-up flag. For example, if a user has signed up in Airbnb, and he will get a sign-up flag here. So the tree is, tree leaf is the hash of the reputation. And the global state tree is, we said before, is the hash of ID commitment and the user state tree root. And when user signs up, and it will insert a leaf in the global state tree in this protocol. And also, a user state transition will cause a new leaf inserted in. And we will introduce the user state transition later. And also, we introduce how the attester can sign up in this protocol. So now the attester is non-anonymous, so the attester can use the Ethereum wallet or a smart contract to sign up in the Unirep contract. And the Unirep contract will assign an attester ID to the attester. Like if the Airbnb is the first attester to sign up in the Unirep protocol, and it will get the attester ID 1. Yeah, so it is the overview of the sign up in the Unirep protocol. The user used the ID commitment to sign up, and the attester used its Ethereum wallet address or smart contract address. And we said before, user used the epoch key to receive reputation. And the epoch key is hash of identity and epoch and nouns. And the nouns is 0 to k minus 1 to let user have k epoch keys in this protocol. And how can we make sure that the user is the owner of the epoch key? And how can we make sure the user doesn't compute the epoch key of, it is not a random number of the epoch key. So we use the zero knowledge proof to let user convince others that the epoch key is computed correctly. Yeah, so it is what in the zero knowledge proof circuit. So we take the epoch and the identity and the nouns here and check if the ID hash, the user state tree root, is together with the Merkle tree proof to see if the global state tree root is matches the protocol. And also we check if the epoch key is computed by the ID hash of ID and epoch and nouns. And the red words here is the private information, and the green words here is the public information. Yeah, so the other user can check that the other user only knows the proofs output epoch key and global state tree root and the valid epoch. Yeah, so when user generates epoch key and epoch key proof, and others verifies it is valid, and then the attester can send the reputation to this epoch key through the Unirep smart contract. And now if we want to make sure that the reputation, it cannot be ignored by every user. So we use the hash chain to prevent users to do this. So we hash the reputation together with the attester ID, positive reputation, negative reputation, graffiti, and setup flag. And each epoch key has its hash chain. So whenever the epoch key receives a reputation, and the hash chain will be computed. So if the user ignore any reputation here, the hash chain result will be totally different. Yeah, so now if the Alice received the 5 reputation from Airbnb and 3 negative reputation from Twitter, but now the Alice user state tree hasn't been updated now. So in this protocol, we use a epoch transition and user state transition to let Alice proves that he owns this epoch key and process this reputation and receive this reputation. Yeah, so in the epoch transition, the hash chain of the epoch key will be sealed to make sure the epoch key cannot receive the reputation anymore. Yeah, so and then the epoch tree will be computed, and the index of it is the epoch key, and the value of it is the sealed hash chain. And this tree is also used to prevent user ignore any reputation. Yeah, so how can user receive the reputation? For example, the user want to the user will perform a user state transition from epoch N to epoch M. And then it is what she will do. The first one is that he will prove that he has signed up or he has performed the user state transition in epoch N and process all the attestation. And final, it will compute a new global state tree leaf in epoch M. Yeah. And it is how the user state tree updated. Like, for example, in a initial user state tree, it will be empty. And if a reputation comes, and we update the fourth leaf, and it is index 3. And the leaf will be hash of the positive reputation and negative reputation and rest of it. And also compute the hash chain. And the second reputation comes, and we update the user state tree according to the attester ID, and also compute another hash chain. Yeah, so after we process all the reputations, we will have a hash chain of all epoch keys and the updated user state tree root. And then in the circuit, we will use the identity and epoch, and we iterate all the nouns, all the possible nouns, and to calculate all the epoch keys the user has in the current epoch. And then we use the epoch tree to compute the epoch tree root. Like we check the epoch key and the sealed hash chain in its leaf, and then to check all the epoch key and sealed epoch hash chain match the same epoch key root, epoch tree root. Yeah, and then remember that we have updated user state tree root, and then we will compute the new global state tree leaf with hash of identity and the updated user state tree root. And we also compute nullifiers called epoch key nullifiers. And it is used to prevent user from performing double user state transition. Yeah, so if the user generate the user state transition ZKP proof and submit it to the Unirep smart contract, and everyone in this protocol can verify if the proof is correct, and then if they are correct, then update the global state tree. Yeah, then after user receives this reputation, and he can voluntarily really prove how much reputation he has. For example, we can prove the reputation is bigger than the minimum reputation we set here. For example, if Alice have 100 positive reputation, then he can choose to prove I only have 10 here. And also the pre-image of gravity. And the gravity can be set of any string. Yeah, so it will make the reputation system more you can have more option to prove things in the reputation system. And also user can prove that if the user has signed up in the attester's application. And the idea to prove the reputation here is that we can compute the user state tree leaf by hash of the reputation, and also check the user state tree root and hash of identity is one of the global state tree leaf. We can see in this picture. Yeah, the left-hand side is the user state tree root, and its leaf is hash of all the reputation from one attester. And the right-hand side is the public global state tree. And the user's leaf would be one of the leaf in the global state tree. Yeah, so here's the overview of Unirep protocol. The user with the public identity commitment will sign up in the Unirep system, and the attester can sign up with its Ethereum wallet or smart contract address. And then user generates an epoch key and epoch key proof and submit it to Unirep contract. And then the attester will give reputation to this epoch key. Then it will perform every certain epoch length, the epoch transition will be performed, and the epoch will increase by 1. And all the epoch keys will be sealed, and epoch tree will be computed. Then how user receives reputation is that user will generate a user state transition proof according to all the epoch key he or she has and process all the reputation. Then the user will, according to the reputation he has, to update the user state tree. And then check the epoch tree roots if they match the same one. And then others see this user state transition proof and verify it is valid, and then update the whole Unirep state. And if user has one of the leaves in global state tree, and he can prove that how much reputation he or she has in the Unirep protocol, and use a reputation proof to convince others. And there's one of the example of Unirep protocol. We built a social media called Unirep Social, and it is a decentralized and anonymous social media. So user can publish a post and comment others, and also upvote and downvote others' post or comments or post or comments. And user in the post can optionally reveal how much reputation he or she has. And instead of user has a real name or account, it will reveals only the epoch key, and it just looks like a hash of it. So it can preserve the author's privacy. Yeah, and we build this system we build the anonymous social media with a reputation system is to force users to take responsible for what they say in the decentralized social media. Yeah, and this is one of the example of Unirep protocol, and more applications that with reputation requirement is also welcome to build upon the Unirep protocol. And here's our GitHub and documentation. Yeah, and also welcome to join our Discord to discuss this protocol with us. Thank you.